I'm a long, long way from home. Traveling down another road, I've lost myself, thrown away my soul. Loneliness was the trip of my lifetime. The ocean waves would carry me by. Still not sure what I'm running for. The search continues along the shore. Rid these demons from my inner core. Afraid I've got no fight left anymore. And I'm a long, long way from home. Was too ashamed of what I became. Now I roam. And I've been away for so long. I'm biding my time, drifting through life, still unknown.
Let's talk some more about safety management, specifically identifying hazards and planning for safe operations, which is crucial for a safety system to be successful. Sorry about that. I guess I wasn't done listening to that song. And as I was saying, we're continuing our discussion of planning and hazard identification. Now, this video we're focusing more on the planning side of it. And my title slide here, I have a little play on words. Safety is no accident. Grammar's not that great there. Safety is no accident. But what I'm really getting at with that play on words is that safety within a company does not happen by accident. You don't flip a coin and come up with a safety plan and it's going to be successful. To minimize employee exposure, to keep employees safe, it takes a lot of planning, a lot of critical thinking, a lot of work in advance for your operations to be safe. You know, there are companies out there that don't put the planning into it, that maybe kind of thinks that it does happen by accident. You know, well, either, you know, accidents are going to happen, there's nothing we can really do about it. You know, everybody wear their hard hat and we'll be okay. That's not professional safety management, and we're seeing fewer and fewer companies like that, but they are still out there. You know, the good companies that take safety seriously, they invest a lot of time and energy into planning for safe operations. And I cover this topic in much more detail in other classes, so I'm not necessarily going to be as thorough. I'm not necessarily going to go step by step in a lot of detail in our discussion here. It's a review for many of you. If it is the first time you've seen it and you're not quite sure what the process is all about, don't worry. You will have exposure to safety planning processes in other classes. The planning all starts with the company's written safety program, which we talked about in the last unit. And I want to mention it again just briefly because it is the general planning document. It's the corporate game plan for safety and how we're going to achieve safe operations within the company. But that's not enough. Even the companies that aren't that good at safety, they may have a written safety program, but that's not enough when it comes to planning. You need to be a lot more detailed, a lot more thorough in your planning. You need to engage in site-specific work and operations planning. A work plan is essential. Now, what I call a work plan, what we call the work plan at Kiewit, it may be called something else at another company. But a work plan is basically a step-by-step rundown of everything, every step that's involved in a work operation and a task. It's in proper sequence. We do this first, this first, this first, and this first. Following that work plan, we conduct hazard assessments or hazard analyses. The hazard analysis is followed by a risk assessment. After we have thoroughly assessed the risk, then we engage in what's referred to as risk mitigation, or implementing controls that will protect workers, that will achieve as much as we possibly can in terms of safety in our operations. And this is just a very general overview of the planning process that goes into safe operations. We'll talk in more detail, and I'll give you more examples and more different tools that are used in the planning process or result from the planning process as we move along. It's also important, and this is where even some of the good companies fail. Planning, when we plan our operations, we need to consider what we're going to do when our original plan is no longer applicable, when there's change. We need to plan for change. We need to conduct a change analysis. At Kiewit, we had very specific guidelines to follow. If something out of the ordinary occurred, something that we didn't consider in our original plan, then we stopped everything we were doing and we talked about the change. And we considered whether we needed to change our safety plans because of the unanticipated change that occurred. A lot of accidents occur when changes occur, when there's a change that wasn't expected, when it's introduced into the work process, weren't prepared for it. That leads to a lot of accidents, and sometimes serious accidents, when that change is not accounted for. Generally speaking, when something unexpected occurs, everything needs to stop. You need to reconsider the circumstance. You need to engage in another level of planning when change occurs. Ultimately, we're going to develop safe operating procedures. And safe operating procedures, not all companies use that terminology. In fact, we didn't even use that terminology at Kiewit. We had different terms, but ultimately a safe operating procedure is a specific procedure that, if followed, should result in a safe operation. Again, it all goes back to the work plan, the hazard analysis, the risk assessment. It's all bundled into the development of this safe operating procedure. And I'm going to talk more about safe operating procedures and some of the other terms that can be used interchangeably with safe operating procedure before we're done here. Talk a little bit more about work plans or operations plans. It's a step-by-step of the activities associated with a specific operation. You got to know the process. You got to know what's happening in the work process before you can plan for the safety of that process. If you don't know the sequence of events, you don't know exactly what specific tasks are going to be performed as part of that operation, then you're really not able to put together a safe operating procedure or any kind of operation safety plan if you don't understand the plan. First step, know what's going on in the work process. That's the work plan or the operations plan. Ideally, this is completed by the frontline supervisors. The project manager also should be involved in this process. Once the work plan is developed by the project manager, the frontline supervisors, it's going to be reviewed by the safety manager. And here's an example of a work plan form that we used at Kiewit. Here is the specific part of the form where the project manager, the superintendent, the foreman, they identify the work sequence step by step. Step 1, we're doing this. Step 2, we're doing this. Step 3, we're doing this, so on and so forth. Once you have this work sequence all laid out, then you can go to the next level of hazard identification and planning. And that next level is the actual hazard analysis. We identify hazards associated with each stage of the work plan. And I feel like I should be giving you more thorough examples here, but again, this covered thoroughly in other classes with multiple examples of this work plan hazard analysis process. So we're just skimming the basics here in this video. Again, identify hazards associated with each stage of the work plan. It should be specific to the operation, or the more specific your hazard analysis is to the operation, to the task, the more effective it's going to be. But a general hazard analysis may also be useful as a preliminary when a project begins, or when there's a new facility that is commencing operations. But generally speaking, more specific the better. A task-specific hazard analysis, again, ideally it's completed by project managers, frontline supervisors, with input from safety management. And I say ideally. There are some companies out there that are not going to require their frontline supervisors to do this. If that's the case, then as a safety manager, we should do what we can to perform this hazard analysis and then share that information with the workers, with the frontline supervisors. And I was really spoiled coming from my previous employer. I know you're getting sick hearing about Kiewit, but the safety manager job at Kiewit was really the easiest I ever had, because they had this culture in place where all of these other people were involved. We were there as a consultant almost. We reviewed the work plans. We reviewed the hazard analyses. We didn't have to do all of this. We were there as a support person, as a consultant, to use that term again. But there are other companies where there's not going to be the management support for getting other people involved, other people besides safety management professionals. But in those circumstances, I still encourage safety management professionals, even if it's not the ideal circumstance, still have some type of hazard analysis process in place that's going to be beneficial to your company. Again, you may have to do the bulk of the analysis yourself, but it is beneficial, even if you have to do it all yourself. And here is a hazard analysis form from Kiewit, again, that would be filled out by the foreman, by the superintendent. Here's the step-by-step plan. And notice there are only 6 steps in this hazard analysis form. We kind of had the view that if it was more than 6 steps, then we should break it down into 2 hazard analyses. We wanted to be focused. If it was more than 6 steps, well, it was, we need to break that down even further into a separate task, to a separate operation. In this form here, we have the different risks that are a part of the operation, checklist type of section of the form, PPE that's needed, or any unique PPE that's needed, in addition to what would normally be worn by Kiewit personnel. We had information. We were real big on what we call access at Kiewit. You have to have a safe way in, safe way out. You had to have good housekeeping to provide good access. So if there was anything unusual about the location that would cause access problems, we had to identify that. We had to identify the type of access. If we were using stairs or ladders or other devices to gain access to the work area, that had to be identified. Were there any ergonomic risks? Lifting, repetitive motion, vibration, awkward posture, which most workplace injuries fall into the category of ergonomics related injuries, so that's very important also. But in addition to this page, here's the page where step by step, what is the worst that could happen? This is the way we encouraged our foremen to do their hazard analyses. And our foreman would do this usually working with members of the crew. Here's step one, guys. Here's what we're doing in step one. What do you think is the worst that could happen? How can we eliminate or reduce the exposure to this hazard? We'd also ask for step one. How are you most likely to get hurt? Then our prevention plan. Also for step one, whatever step one may be, are there other risks that we need to be aware of, and how are we going to control those risks? Then once you talk about step one in the process and the sequence, then you talk about step two, step three, and so on. And all the way out through step 6. I'm not showing you the whole form. But a Kiewit foreman, they needed to have a filled out hazard analysis ready for anybody to look at. If they didn't do their hazard analysis and a member of management or safety management asked for it, they didn't have it, they're in deep water, deep trouble for not having that form. But the foreman that ended up working at Kiewit, at companies like Kiewit, this is part of their work. They didn't complain. They did it. They understood the importance of it, the importance of this planning. As a safety manager, part of when we would go to a project, when we were on a project, we would review these forms, these hazard analysis forms. And one thing I need, I almost whiffed on this one. One thing I need to emphasize: a hazard analysis is not the form. Hazard analysis is not the form. Hazard analysis is the critical thinking process that's recorded on the form. We're just using this form as a way of documenting the process. Filling out a hazard analysis, if it's not done correctly, if proper critical thinking hasn't gone into it, then that piece of paper is worthless. Hazard analysis is the thinking process. Thinking about the hazards at each stage in the process and how we're going to control those hazards. Another stage in the planning process is risk assessment. Risk assessment, very simply, you can have a whole chapter on risk assessment in a safety management book, or maybe multiple chapters, but very simply, it's when we identify the highest risk activities and make those a priority. We identify what is most likely to hurt someone and what is most likely, or what kind of incident will result in the most serious injuries to workers. What types of incidents will result in hospitalization? What type of incidents are most likely to result in a fatality or an amputation? What types of incidents are most likely to be of a catastrophic nature? So we look at frequency and we look at severity. Here I have it down as probability and severity, but you'll see and I actually prefer frequency as the variable. How likely is it, or what is the level of frequency with which we will be exposed to certain hazards? What is the level of severity if an incident occurs related to those hazards? Those are the variables in general we're looking at when we determine the level of risk. We determine the level of risk and we knock the hell out of the highest risk operations first. That's our priority. What you see here over on the right is a risk assessment matrix, which I talk in greater detail about the risk assessment matrix and how to use a matrix like this in other classes. But you'll often see this used as a tool to help with the risk assessment process. The textbook risk assessment procedures, they can be very complicated, overly complicated, unnecessarily complicated. I prefer to keep it as simple as possible. And one of the best methods, practical methods, that I found for conducting a risk assessment is asking workers these two questions. Question 1, how are you most likely to be injured? Question 2, what task out here on their job is most likely to put you in the hospital or kill you? Looking at those two questions and their answers to those two questions is an effective way of identifying the highest risks and the highest priorities for a project, an operation, a task. And there are some safety professionals out there. Hopefully there aren't a lot of them in this day and age, but there are some safety professionals out there. They do all their risk assessments in an office. But we need to be involving workers in this process and asking the workers, what is the highest risk? Or more specifically, ask them these two questions, which will allow us to get at the highest risk in the work process. The workers, they probably know better than the safety professionals in many instances what the greatest hazards are, what the greatest dangers are in a work process. So involve them in that process. Again, ask them these two questions, and that's going to tell you pretty quickly, 90% of the time, what is the highest risk, what is the highest priority in your work activities. Once we conduct the risk assessment and we identify what is the highest risk, then we want to identify specific control measures that's going to mitigate those risks. Mitigate is a fancy safety professional term for control those risks. How are we going to control those risks? How are we going to reduce the impact of that risk? Again, depending on the hazard, there can be multiple control measures. It's not necessarily going to be one. It's all task dependent, hazard dependent, what our control measures are actually going to be. But we do rely on what's referred to as the hierarchy of controls when it comes to identifying mitigation measures or control measures. There are 5 levels in this hierarchy. The first level is elimination. We come up with a plan to eliminate the hazard completely. And maybe we're eliminating the hazard by changing the work process. An example that we would use in the bridge building industry. Instead of having workers bolt together the steel girders 100 feet up in the air, we would have them bolt everything together on the ground, bolt all the girders together on the ground, then we would lift the whole assembly and set it up on the piers, on the pier caps. That eliminated a lot of the falling risk associated with that stage in the construction process. The next level, considered the next most effective control, is substitution. And my example here of substitution has to do more with chemical hazards, but there may be other examples of substitution that would apply to non-chemical hazards. But let's say we have a chemical hazard. We can mitigate that chemical hazard by replacing the dangerous chemical with a safe chemical, using a safe chemical instead of a dangerous chemical. Again, substituting safe for dangerous. And from my bridge background, a perfect example of this, in the early days of concrete-related construction, for form release oil, they would spray diesel fuel on the concrete forms. Diesel fuel is not the safest thing to be using to spraying around. I mean, it's not the most dangerous either, but it's not the safest. Over the years, as technologies developed, new, safer form release agents were developed. There are form release agents in use today, and I say widely used today. Most companies are going to use safer form release agents that are a vegetable oil-based chemical compound. It's basically like putting Wesson oil on your concrete forms instead of using diesel fuel. Now, the old timers, they might still want to use diesel fuel, but there is a safer option out there that you can. There is a substitute for diesel fuel. The next most effective level of control would be engineering controls. Examples of engineering controls would be using machines or devices to protect workers. A good engineering control will protect the most dangerous, most careless worker on your job site. You take the worker completely out of the loop and by your engineering control. A real good example of engineering controls would be a seat-activated kill switch on a piece of heavy equipment. The operator is sitting down on the piece of equipment. The equipment will run just fine, but as soon as he or she stands up, the machine shuts down. That protects the worker from getting run over or crushed by their own piece of equipment, which does happen. One of the fatalities that I had to work with was a worker who was crushed by his own machine when he left the machine running and then got off the machine to try to do something. And we'll talk more about that accident as the semester goes on. I'll go into some detail talking about that accident. But and there's a lot of different engineering devices, different machines, or different. It could even be an engineering strategy that's used to protect workers from the dangers in the workplace. And like I said, and I'll reemphasize this, and I go to great lengths talking about this in applied safety engineering. Good engineering controls will protect your most careless worker. A worker could be half asleep throughout the workday in one of the most dangerous work environments out there. If you have good engineering, then they're not going to be able to hurt themselves. Even if they're trying to hurt themselves, it's going to be hard for them to hurt themselves if the engineering controls are adequate. Okay, these are the most effective, and this is the level of control that we should try to implement for the hazards that we identify. But we're not always going to be able to identify an engineering control. We're not always going to be able to substitute or eliminate completely. We might have to go to the next level, which is administrative controls. Administrative controls include the use of rules, changing work practices, job rotation that we talk about in industrial hygiene. That's an example of an administrative control. We talk a lot about signs in safety management. A sign is an administrative control. The downside of an administrative control is that they can be ignored. They're not if a worker ignores the rule or if they ignore the sign, then they're not effective. That's the downside of an administrative control. The lowest level, the last resort, the least desirable, is PPE, or personal protective equipment. Personal protective equipment, different types of protective clothing or devices. Hard hats, safety glasses, steel-toed boots, steel-toed safety shoes, all examples of personal protective equipment. They are important, but they are the least effective level of control. As safety managers, we should try to implement controls at the higher level, ideally at the engineering level or above. The engineering level or above, that's going to give the highest level of protection from hazards in our workplaces. PPE, a lot of companies out there, and you've heard me rant about this before, a lot of companies, that's all they do is PPE, and they think they're doing a good job. Well, that's BS. PPE is the lowest level. I go into a company as a consultant and I ask them about their safety program, and I start talking about all the PPE their employees wear, and that's the best they can do, then I'm immediately unimpressed and immediately concerned about their safety system and their understanding of hazard control. They don't really understand it if PPE is all they're doing. And there are companies out there like that. So be prepared. Hopefully you won't go to work for one of those companies, but if you do, you'll have a challenge ahead of you trying to change their thinking, trying to impress upon them the importance of controlling at these higher levels. In this last segment, we're almost done here. I just want to very quickly talk about some specific planning activities. And again, understand that the more focused or the more micro level we are in our planning activities, the better. The more site specific we are, the better. And what I'm going to go through here is I'm going to go from the general to the specific. Again, much more detail in other classes. Some specific planning activities and documents that may be prepared to document our planning activities. Again, we start with a general safety plan, such as the company's written safety plan. Very general coverage of the company's safety policies and practices. A little more specific, a little more focused. We could be involved in creating and implementing a project or facility safety plan. This is more site specific. And a site specific safety plan, this is an acronym that you might see in a lot of companies, the SSSP or the SSSP, site specific safety plan. A more focused plan acknowledging and addressing unique hazards of a particular facility or project or work site. More specific, more micro, we get to the level of operations safety plan or a safe operating procedure. Focus on a specific operation or specific operations within a project or facility. For example, you have your company safety plan. Let's say you're a manufacturing company and you have your company safety plan. Then the next level, you have your facility safety plan. Then on this level, more micro, you have a specific plan that focuses on the warehousing and transportation operations at your manufacturing facility. If you're in the construction industry, you can have a project safety plan, which is based upon the company safety plan. Then you get to this level, you could have a safety plan or a safe operating procedure that focuses specifically on all of the crane-related activities on a specific construction site. Companies, depending on the chemicals they work with, could have a specific plan for how to safely handle different chemicals in their workplace. These would all be examples of operation safety plan, safe operating procedures. Oh, by the way, I should have mentioned this sooner. If anybody would like examples of any of these activities or planning documents, I've got 20 years worth of examples that I can share with you. I've got operation safety plans, SOPs, which are really the same thing in my book, but they're just different titles. But I've used both in my career: operation safety plan, safe operating procedure. I've got company level safety plans. I've got project level safety plans. At Kiewit, every project we had a project safety plan, a site-specific project safety plan. My company before Kiewit, I was starting to get them to the point where they were starting to think about project planning at that level. They weren't quite there yet when I went to Kiewit, but those are best practices. What I'm describing here are best practices. None of this is necessarily OSHA required. But it's not about OSHA, as you've heard me say before. It's about doing what we can to keep workers safe. It's doing what we can so that we don't have to go to a co-worker's funeral. That's much more important than avoiding an OSHA citation. So the next level, we're getting more specific. Let me back up just a second here. We go from a general safety plan to a more specific project facility safety plan. Then we go to an operation safety plan. Now we're at a task-specific safety plan. Now some companies are also going to refer to this as an SOP or a task level safe operating procedure. But this is, again, breaking it down to the more micro level. And here's examples of what we're talking about. Again, focusing on a specific task that is part of a larger operation. Something as simple as refueling a forklift. Good companies will have procedures and plans for something that simple. And forklifts, if proper procedures aren't followed, there can be fires, depending on what kind of fuel, what kind of power source runs that forklift. Refueling is pretty critical to the safety of that operation. Another example of a task-specific safety plan, the maintenance procedures for a specific industrial machine. If you have a specific type of machine in your manufacturing process, well, you should have a specific plan for how that machine will be maintained. How lockout tagout will be used. What are the lockout control points for that particular machine? What is the sequence that needs to be followed in the lockout tagout plan, and so on. Back over to the construction industry. If you have what's referred to as a critical lift, that needs to be planned. We had critical lifts at Kiewit that we spent a month in planning just for one lift. If you want to know more about what makes it a critical lift, email me and I'll share that information with you. But beyond the scope of what we're talking about here. Another example, though, of a task-specific safety plan or a task level SOP would be crane assembly or disassembly. One of the most dangerous things you do with a crane is putting that thing together or taking it apart. There are big, heavy components that can fall on people and crush them. You got to have a plan in place to help ensure to improve the safety of that operation. It's also, I believe, important for companies to have some type of pre-operations planning process. This goes along with, in addition to what we've talked about already. Pre-operations planning is the planning that takes place before a work process commences. Can take several months or can take a few days to perform the required planning. This pre-operations plan ideally will be reviewed by upper management prior to the operation commencing. Prior to operation commencement, prior to starting that operation, it's going to be reviewed not by safety managers only, but by upper management as well. Companies that do this management review, they've got different terms for it. Some companies call it a handoff meeting, where everybody gets together, they talk about the plan. Management, they kick in their 2 cents worth, their thoughts, things that need to be improved, and so on. Another term, this is a term we used at Kiewit, and other companies use this as well, is a readiness review. Before that operation starts, there's a meeting where everybody gets together and they talk about the plan. Are we ready for this operation to commence? Or do we need to go back to the drawing board and do some more planning? And at Kiewit, if you weren't ready to kick off a project, you would hear about it in that readiness review, and that might delay the start of the project because more planning needed to take place. Again, like I've said before, I'm contrasting Kiewit with other companies. Other companies may not have this level of planning involved. My second company, we got to the point of doing handoff meetings before each project started. We called them handoff meetings. But it kind of fizzled. We got off to a good start with it, and then upper management lost interest in it. And if you don't have management behind it, it's not going to be as successful. But these are best practices if we can get them implemented into our companies. Again, I talk a lot about construction. That's my wheelhouse, but it's not just construction. any industrial operation, any industry can utilize a variation on this pre-operations planning process. After it's been approved by management, the next step would be a worker orientation. Make the workers aware of the plan, get their input, ask them if they have any ideas, any holes that they see in the plan, anything that they're concerned about. Get the workers involved. Now, the frontline supervisors should be involved at this level. Now, they're not always going to be, but they should be. There should be someone, say at a superintendent, foreman level, involved in the readiness review or the handoff meeting. But that's pretty much it. It's, again, very simple, very quick and dirty overview of the pre-operations planning process. And that brings us to the end of this video, and I just really do want to emphasize the importance of planning. Safety is no accident. It takes work. It doesn't happen by chance. It takes work. It takes planning. The safer companies put more time into the planning of their operations. They don't take things for granted. They don't automatically assume that, well, he's done that for 15 years, so it's going to be okay. You dot your I's, you cross your T's, you do your planning, you control for every possible contingency. And then you also are prepared for when something unanticipated happens. When something unanticipated happens, you go through that change analysis process. How does this change affect the safety of the operation? What do we need to do in our plan to counteract the change that has occurred? And much more to this process, and these are the classes where, if I'm teaching these classes, I go into much greater detail on the planning process and how the planning process relates to safe operations. A lot more examples, more hands-on. In applied safety engineering, I actually have students do a hazard analysis after we've talked in detail about the process. But 3403, safety administration programs, applied safety engineering. I also talk about planning in machines and materials, and also process safety management. In process safety management, I talk about military standard 882, which is where a lot of our best practices in safety management comes from. It's the systems safety standard that was developed within military circles over many, many years, and the good companies have adopted some of those best practices. Hazard analysis, risk assessment. It really all started with military standard 882. If anybody would like a copy of military standard 882, let me know. I'd be more than happy to share it with you. If you've been in 3413 or 4453, you've already had the opportunity to download a copy of it from Blackboard. But if anybody in here would like one, you haven't had the chance, I'd be more than happy to share it with you. For those of you, who may be taking your first safety management class, don't freak out over all this. Even though I was I wasn't very thorough in describing the planning process in this class, you will have other opportunities. I think I talk about planning so much, hazard analysis and risk assessment so much in my other classes because it is, I talked about the 5 E's and a P. The P is for planning. It is absolutely essential for companies to achieve safety management success. You got to do your planning. You got to do your homework. You can't just roll out on the job site or roll out on the factory floor and expect everything to go well. You got to prepare. Preparation is the key. Planning is the key. Having said that, I will let you go. There's more information in Chapter 3 of your textbook related to what we've talked about in the 2 video lectures. Let me know if you have any questions.